So the only difference between this and what we did first quarter is that this has fractions in it. That's the only difference. And a lot of times the fractions, we are multiplying. I said a lot. That doesn't mean all of them. We just finished last quarter learning how to add fractions. So does that mean that because we're in third quarter that we are never going to add fractions? No. So there's adding fractions in here too. Adding fractions does not go away. Once you learn how to do it, you're going to be doing it. They're going to keep throwing it at you. So you can't go, oh, new quarter, new stuff. I don't have to remember how to do that stuff. You have to constantly remember how to do it. So we're going to look at this, and I'm going to be underlining things with two different colors to remind you how we do this. Now, one of the things they say, write an expression. An expression is just the number sentence. What would the number sentence look like? Now, that number sentence is not, I went walking down the street with 2 dogs. That is not a number sentence. A number sentence is the thing like 2 plus 3 that you would solve. When you see the word evaluate, evaluate is a fancy word for solve. That's all it means. So when you say 1/6 the sum of 16 and 20. So when I have my 2 colors, I have 1/6 the. 1/6 the. What am I having to take? 1/6 of. What am I having to do? 1/6 of what? That's not what I have.
16 and 20.
What about 16 and 20? What am I doing?
Add 16 and 20 to get your answer.
So it's the sum of 16 and 20. Oh, yeah. They kind of like, I remember it now. It's like you haven't ridden a bike for several years and you're starting off kind of wobbly, and it's like, oh, yeah, I remember now. So 1/6 the sum of 16 and 20. So if I had to write this as an expression, 1/6 the means I'm taking 1/6 and multiplying it by something. Because one's a fraction, the. So when we have a fraction, the, we just learned today that a fraction, the, means multiply. Sum. You have a problem? She said, please stop. She was polite. So then sorry, if you were banging your pencil on the desk, it's irritating. Turn around. May not be irritating to you, but it's irritating to others. So sum means add. And what are we adding?
16 and 20.
16 and 20. Okay. So now I have to figure out where my parentheses go. Is it going to be here? Is it 1/6 of 16? Or it's 1/16 of 16 and 20?
Yes.
Yeah, so it's there because it told me it's 1/16 of the sum of those 2 numbers. Oh, yeah, okay. I'm remembering now. I get it. Oh, yeah. So now it's telling you to evaluate. Now you've got to solve it. So the first thing you have to do, if you guys, I gave you those charts a while back, but the one thing I don't like about those charts, PEMDAS, please excuse my dear Aunt Sally. The one thing I don't like about the chart is it's going in this order where, of course, we know that parentheses comes first. Okay? But the one thing that I don't like, one, we're not going to be really doing exponents this year. That's a higher grade, so you're really going to skip the exponents. But it makes you think that multiplication is more important than division. It's not. Multiplication and division are equal partners. Because they're in a fact family, they're equal together. So whenever I write it, I do multiplication, division. They're equal, as are addition and subtraction. They are equal. So, set them down. Awesome. So, multiply and divide are equal. So if I were doing a number sentence that had like 2 times 5 divided by 2, and it's all that I had in that number sentence, I go left to right. Because they're equal. I don't do multiplication before division because multiplying is more important. They're equal, left to right. Just the same as adding and subtracting. If I had like 12 minus 7 plus 6, I don't do adding first because adding is first here on the chart. I go left to right because adding and subtracting are equal. And that's all I have in that number sentence. Does that make sense with the please excuse my dear Aunt Sally?
Yes.
I mean, we'll do more of order of operations. It's just when we're doing these expressions, these written expressions, sometimes you do get into order of operations and you need to kind of know it. And I don't know how much you did it in 4th grade. Okay, but where we kind of touch on it and then we get away from it and then we touch it and we get away from it. So it's, you know, it's kind of, we haven't really gotten into it yet. Okay. So we do 16 plus 20, 36. Then we have to take 1/6 of this. We do have to multiply. So 36, 6. Can I leave that as my answer? No. You cannot leave an improper fraction as your final answer. Thank you. As your final answer. You have to get rid of the improper fraction. You cannot leave it. I still had some people on that quiz leaving me with improper fractions as their answers. You cannot do it. I will not allow it. I will mark it wrong. 6 into 36 is 6. Your final answer. Okay. Subtract 5 from 1/3 of 23. So the first part, I am subtracting 5 from something. So what am I subtracting 5 from? Carlasia, what am I subtracting 5 from? 1/3 of 23. So my 5, is it go when I do this, is my 5 going to go in the front of the problem or in the back of the problem?
Front.
You're guessing. Listen to it. Subtract. Listen to the problem. Don't guess. Subtract 5 from that. It goes in the back. If it's in the front, it would say 5 minus. That says 5 from it, which means I've got to do the work, and then I've got to take 5 from it. So 5 goes in the back. So when you write that, 1/3 of 23, how do you write that? How would you write that, Anthony?
1/3 times 20.
Yep. 1/3 times minus 23 in parentheses minus 5. Okay, so I want to see if you guys can actually solve that. See if you can get me the answer. All right. So right here, you should get 23/3, right?
Yes.
Okay. So if you did it right there, you're good.
Okay.
Now I've got -5. Well, I can't really do that right now. So I'm going to turn this into a mixed fraction. So 7 2/3. You should be right there. You should be able to get a mixed fraction right now. You should know how to do that. Now, -5. So if you got this far, good for you. Now, this is one little part. I wanted to see what y'all would do if you got right here. Now, if you did 4 3/3, you ran into a problem because you've got 2 and you can't subtract 3. You can't do that. Now, I want you to think about this for a second. Pulling out the pizzas. You ready? Hey, it helps you figure out fractions, right?
Yeah.
I've got my counter. I've got 7 uncut pizzas and 2/3 of a pizza. Can I get someone 5 uncut pizzas? There's no technically. Can I get someone 5 uncut pizzas?
I just
4, 5, 6, 7. So, can I give away 5 of these?
Yes.
So, it's 2 2/3.
I only got the 2.
Now, the part, so I can add and subtract a fraction with a whole number. I can add anything. When you're subtracting, you can subtract very easily when the plain whole number is in the back. You just can't do it when it's in the front. I just wanted to see what you would do if I didn't say anything. If I had, just like with that 10, say you had 10 minus 7 2/3. That's when you can't do it. That's when you have to take a pizza and slice it. When it's in the back, okay, take 5 pizzas, have a ball. Now I've only got 2 and still got 2/3 that no one wants. See?
Okay.
All right. See if you can write the expression this time for C and D. Three times as much as the sum of 3/4 and 2/6. 3 times 3/4 plus 2/6. That's what your expression should be. Now I cannot add these because you cannot add those because you need a common denominator. My least common denominator, because I don't just multiply stuff together, is actually 12, because I hate simplifying fractions. 4 to get to 12 is 3. 3 times 3 is 9. You could have done 24, but I don't want to do 24. 6 to get to 12 is 2. 2 times 2 is 4. 9 plus 4 is 13. 3 times 13 twelfths. Now, there's 2 ways you could do this. You could just multiply straight across and do 3. Why are you making a face, Stanley? About what? Because I didn't put my common denominator 24. I could have gone to 24 and then my fraction would be a lot bigger. I didn't want to. OMG, if you had done 24, gosh, 18, 24, 8, and you would have had 26 over 24. I didn't want to go that big.
Oh, hold on. I kind of messed up.
Okay, and then you would still have 3 times 26 over 24. But see, I didn't want to go that big. Least common denominator. So, anyway, as I was saying, you could multiply straight across, which is how you multiply fractions. 3 times 13 is 39. 1 times 12 is 12. And then you make it a mixed fraction. 12 goes into 39 3 times, which is 36. And then I have 3 twelfths. There's more than one way to do this. Which is 3 and 1/4. You actually, and then that big old mamma jamma. 26 times 3, 18, 78. Yeah, see, I don't like these big old numbers, which is why I do a common denominator. 24. I know it's got to be 3. 2, 1, 72. 6. 3 and 6 24ths simplified would still be 3 and 1/4. And see, it's not even complicated. It was just another way. So you could take 13 twelfths in the middle of the problem, which is one of the things that I say don't do. But you could, but I mean, this still, you still get the right answer. Sometimes it's harder for the problem to make it mixed in the middle of the problem. Sometimes it's easier to make it mixed in the middle of the problem. You could take the 13 twelfths or the 26 24ths and go ahead and make it a mixed fraction, which I wouldn't have done, but it's okay. You can still get the same answer. So 13 twelfths would be 1 and 1/12, okay? You don't have to write all of this stuff down. It's just really which method you chose. There's this one, or this one that I'm writing right now. So there's 3 times 1 and 1/12. You can multiply a whole number times a mixed fraction. What you can't do is multiply a fraction times a mixed fraction. Okay? I can do this. I cannot do this. Okay? So if you end up with you will have problems that have this. You'll have to make this improper, then work it. Okay? So for this, it's super easy. Whole times the whole. Whole times the numerator. Because it's 1 1/2 plus 1 1/2 plus 1 1/2. Oh, sorry. Well, so it's repeated addition. So it's 3 copies of 1 and 1/12. So that's why it's 3 times the whole number, 3 times the numerator, and you leave the denominator alone because you never add your denominator. That's how you get 3 and 3/12. You multiply the whole times the whole times the numerator, leave the denominator alone. So there were multiple ways that you could solve that problem. Okay. So the next problem. So yeah. 2/3 of the product of 5, 6, and 42. What? What's the common denominator of 6 and 1? Oh, that's right. Okay, so 2/5 of the product of 5, 6, of 42. That's what you should have. Okay. And by the way, if you ever have like 1/2 plus 4, you don't have to find a common denominator for that. It's 4.5. If I have a 1/2 cup of water and 4 cups of water, I have 4.5 cups of water. You don't have to find a common denominator for that. Well, because you didn't see what she was doing up here. Okay, because that's a whole number. All right. 5, 6 of 42. Can I do some 2.0 in that? Yes. Can you?
Yeah.
Yes. Yes. I don't know. Yes. You can.
7.
Oh my gosh. Yes. 35. That was cute. I liked it. It was adorable. So 2/5 of 35. Can you 2.0 that one?
Yeah.
Any number that has a 5 or a 0 in the ones place, 5 can go in it. How many times can 5 go in 35? 7. So what is your answer? 14.
I made that way more difficult than I had to.
Yes. All right. So E and F. 8 copies of the sum. I want you to pay attention to this. 4/3. It says 4. They took a fraction and put it in word form. 4/3 and 2 more.
So 4/3. And then
4/3 and 2 more.
oh.
4 times as much as 1/3 of 8. All right, so let's go over E. When you're sitting there, I'm assuming that you're completely finished because you're not. 8 copies of the sum of 4/3 and 2 more. You guys are making that way harder than it needs to be. 8 copies. You wrote that one down.
Oh.
The sum of 4/3 and 2 more. Now, I saw parentheses in the wrong place. It's 8 copies of this, so the parentheses should be there. Oh. Now, I just got finished talking about if I have 4 cups of water and a 1/2 cup of water, then I have 4.5 cups of water. So I have 2 and 4/3. I don't have to do common denominators or anything. I just take the whole number and I add it to my fraction. I just got finished telling y'all that.
I know, I remember. Oh, yeah, now I can go balance. That's not good.
I know it's improper, but when it's in the middle of a problem, what do? I leave it. I'm going to wait until I'm finished. I'm leaving it because now I could make this 1 1/3. No. Because then it'll be 1 1/3 plus 2, and then I have 3 1/3. Isn't that still equal to 3 1/3 right there? Yeah. And then I have to try to multiply that by 8, and I'm still going to get the same answer. So 8 times 2 4/3. I guarantee I'm going to get the same answer. Okay? Whole number times the whole number times the numerator. 16, 32, leave the denominator alone. 24, 8. Either way, you're going to get the same answer.
Oh, it's just simplify.
But they're still improper. I can't leave it alone. I've got that improper fraction in there. I can't leave it. So 3 into 32. 3 goes into 3 once. Bring the 2 down. 3 cannot go into 2. 0. So that's 10 2/3 for this, plus the 16. So that's 26 2/3. 24 8/3. 3 goes into 8 twice. 2 2/3. 24 plus 2 2/3. Still 26 2/3. It's the same thing. Hadley, you're making a face. About what? Well, that's kind of vague. 4 times as much as 1/3 of 8. 4 times as much as 1/3 of 8. So if you ever write your expression, you really should go back, look at it, and see if it reads like what it says up there. 4 times as much as 1/3 of 8. Because sometimes if you write it wrong, and you go back and you read it and go, wait, that doesn't, no. Like if you put a plus sign when it says product, if you really know what those words mean, you should go, oh, wait, if you put, a multiplication sign for when it said sum, you really should catch it if you go back and read it before you work it. And I know about a handful of you will actually do it. Most of you won't. Handful, I didn't say all. 1/3 of 8. I cannot do 2.0. I get 8/3. So 4 times 8/3. I can do that 2 different ways. I can just multiply straight across. 32/3. So 32/3. I know what it is, but I was just showing my work. 10 2/3. Now, this is when it's actually good to have left it improper because it's less work. Because if I did because I like working smarter, not harder. I hate doing more work than I have to. Because if I did making this a mixed fraction, I would have to do more work. Because if I did this 4 times 2 2/3, I'm just doing this step again. You don't have to write it again. Then it's 4 times 2, 8. 4 times 2, 8. So not only did I have to work on making this a mixed fraction, now I have an improper fraction that I have to mess with. So 3 goes into 8 twice, 2 2/3, plus 8, 10 2/3. So it ends up being a little bit more work because I had to mess with it. It's not wrong, it's just more work. Huh? Huh? Whatever floats your boat. Whatever. As long as I can see your work. Because like I said, if you don't show me your work, it's wrong. That's the policy. Don't show your work, it's wrong. Okay, now for this. This is not as much work as you think it is. It really is not. Circle the expressions that give the same product as 4/5 times 7. And it says explain how you know. Really, your explanation is just showing your work a little bit. I don't need like a paragraph because if you have 4/5 times 7, what is your kind of not full answer, but your partial answer? What would I get next?
You'd get 28 and 5. 28 of 5.
I would have this. Okay? So all I'm looking for is which ones up here would give me that. Oh, I'm not even looking for like the final answer. I'm just like, okay, which one would get me that? So here, 4 divided by 7 times 5. 4 divided by 7 times 5. When you've got that division symbol first, that means that goes on top. I'm writing it like a fraction. No, it's not. 7 divided by 5 times 4. I'm kind of showing you how to write it, and then you're going to have to show me which ones would get you to that point. 4 times 7 divided by 5. 4 divided by 5 times 7. And then those last two I'm not doing. So you circle the ones that would get you there. So will this ends up being 4/35. Will this one be it? No. 7/20. Is this it? No. No, I didn't just hear yes. 28/5. Is this one it? Yes. The third one is it. 4/35. Is this one it? No. 4 times 7/5. Will this one give me 28/5? Yes. 7 times 4/5. Will this give me 28/5? Yes, it will. Is there a leak? Yes. It's not even funny. Yes.
Ouch.
Okay. So with these are the last ones, and if we don't get finished, it will be full. So then we need to get finished.
This one is 6.
So does that 28 over 5? No. 4 over 35 and 7 over 20. Okay. So with these, you have to solve each side and put whether they're greater than, less than, equal to. I know it says to do it without calculating and explaining your thinking. Well, if you didn't have to do it with calculating, I know you would go, oh, there you go, I'm done. I did it in my head, is what you would say. No, you're going to show your work. You're going to do it and tell me if a side is greater than the other side. So all you have to do is solve it. So here I've got multiplication, addition, multiplication. So you have to do 4 times 2, 4 times 2/3, take those two products, add it together. 4 times 2 is 8, plus 4 times 2/3. So 4 times 2/3 is 8/3. If I have 8 plus 8/3, 8 and 8/3. Don't make that harder than it is. Like 4 cups of water plus a half a cup of water is 4 1/2 cups of water. Now, this is improper. For right now, I'm just going to leave it alone because I might not even have to worry about it because this side might just be easy. 3 times 2/3. 6/3. So 6/3 is, it is improper. What is it?
2, 1. I need 2.
What? What? Okay. So which way does my symbol go?
This way.
This way. Do you see how easy that is?
That is so easy.
So easy. So I want you to do this one and do that one. All right.